Cambridge Muslim College, training the next generation of Muslim thinkers.
The title of my talk is The Symphony of Soul and Body, and the rest of it just explains some of the technical language, which is quantum theory, duality and brain dynamics, which relates to from which I'm going to derive the symphony of the soul and body. Now, you'll see what I mean about this. In fact, it's going to be very general, so I realise I lose a lot of people when I'm talking mathematically and using physics, so I'm trying to bring it down to street level, and so that hopefully you'll be able to understand it at a fairly non-technical level. And I'm going to concentrate a lot on the actual significance of the theory as much as the theory itself, if not possibly more. So to start with, the objective of my talk here today will be to look at a very brief overview of what quantum brain dynamics as a model for brain activity is. Now, so I'll explain a little bit more in a minute what I mean by that. And then the duality is a remarkable feature that arises from the fundamental physics of this. And then we'll go on to looking at the striking and remarkable recent findings by Vitiello and Freeman about the relationship between mind and matter. And that's fortunately based upon a lot of empirical data. And then we're going to sort of draw some conclusions by comparison to monotheistic faiths and so forth. Predominantly, these will be fairly broad conclusions, so they apply to all faiths and all philosophical views. So what I just to clarify, I will not be talking about, just in case anyone's any doubt, I won't be talking about computation or AI, because that's not the field I'm in, although computation is a very big area in brain studies, in quantum theory. And I'm not going to address any other models. There are several models of brain function, mainly because they deal with the computational side of things rather than the brain dynamics. And I'm not going to, nor do I pretend that anyone has a complete model for consciousness, because there, frankly, in a single sentence, there simply is not one. And I don't think we're anywhere near finding one. But this hopefully provides some sort of clue as to where we're going. So I'm going to start with the hard problem. Now, many of you have heard of this, coined by the philosopher of physics David Chalmers, and the hard problem is really what this is all about. In fact, I'd say AI should really start from the hard problem, because as somebody said to me in the break just now, it's hard to understand a computer or a program if you don't understand ourselves. So we can't really make sense of if some of the computer has consciousness when we don't even know what consciousness really is. So that's a very sensible statement. I thank the person who said this to me. The point is that this is not a new problem. It's been a problem for over 2,000 years or more. And really what it boils down to is trying to decide whether there's mind or soul affecting the brain, or in some sense, and how do we experience anything whatsoever. And so the three main views on this could be approaches or philosophies are materialism, dualism, and idealism. So with materialism, we're talking about believing that the physical behavior is actually determined by the action of matter with matter. So in a sense, mind has nothing to do with it. We can sort of put it to one side. Henry Stapp, who's very involved in this area of physics, is a very prominent quantum physicist too, has described this once as talking about zombies. Now, what does he mean by zombies? I don't mean the sort of zombies you see on films, but we're talking about if I had to snatch all the consciousness out of one of you and held a conversation with you, but you were still to function. That's what I mean by a zombie. So in a sense, a materialist view would mean that there could be no self-awareness as such, but somehow I wouldn't know about it, were you conscious of yourself or not. And in that sense, you could be a zombie. But the dualist view is halfway between the other extreme, which is the idealism, that the belief that all knowledge and all mental function somehow is dependent, and all physical things are dependent on the activity of mind or higher higher things other than material. So the philosophical view taken by most theological beliefs is really something more like dualism, which originates from, I mean, many things, but certainly explicitly from Descartes, whereby we believe that there are two quite distinct aspects to reality. First of all, there is the material and physical world, and then the other completely distinct thing, which is mind, or something that is actually not physical or material. So, before we go any further, the next question you probably ask is, this is all very interesting, but why am I bothered? In fact, why bother? I can still go shopping at Tesco or whatever. I can still watch a film and, drive my car and enjoy a sunny drive. So why am I bothered? And the answer is that if you are actually going to reflect on yourself at all, there is actually a shocking, I would say shocking, not just striking, deep relationship between man and man's consciousness and the physical universe. And I think to a great extent the general public are not really aware of the degree of this striking relationship, particularly if we look at the probability that we as beings are actually here at all. This is an underestimate, in fact, that if you look at the fine-tuning constant and the cosmological constant and so forth, we find that the probability of us existing at all is less than 1 in 10 to the 120, or in fact much smaller than that. So this is a real Goldilocks phenomenon. We shouldn't, frankly, none of us should be here at all. We shouldn't certainly not be aware of the fact that we're here at all. So why do we exist at all? So if you just put this into context, if you compare it to winning the lottery, approximately we talk about a chance of 1 in 14 million. So the question is, how many of us really believe that when we buy a lottery ticket, if we buy one, which most of us have probably given up, that we would actually ever win it? It's not a very high chance. So yet we actually believe that somehow the universe just came about on its own, but the chance of that is actually colossally less. I mean, from a mathematical scale, we're talking about a colossally small number, so small that you could effectively, or practical purposes, call it zero. So then the other next deep relationship between man, and let me be absolutely bluntly frank with you, this is as a gigantic problem, and an area of physics which is being is an area of great struggle, but to a great extent it's being brushed under the carpet, which is the measurement problem, which is quantum theory is the physical theory of the universe, yet it says that there's some sort of mysterious link somehow between mind and matter. Now, what I mean is that we can't get over the problem that whenever we make a measurement, something like a particle, which in this room, can only take an actual position or develop an actual speed if it is consciously observed. We still don't understand this, and we know that this is still, there are many ways around this problem, but none of them are proven. The other thing is, why do we experience inequalia? I mean, this is, again, another rephrasing of the word, what is the mind-body problem? And then finally, and bear in mind these are just a few points. The other point, which is certainly not to be underestimated, is the fact that there is an unreasonable effectiveness of mathematics, particularly in the natural sciences. And Wigner is a brilliant physicist himself. He's made this statement and published a paper on it. We should not be able to understand anything. Several of us here could possibly pick up a pencil and paper and work out the orbit of some distant, planet or some structure of the early universe simply with a piece of paper and a pencil. The power of the human mind and connection between this physical world is striking. So these are reasons to be worried about ourselves and why we are at all conscious, and why is there such a strong connection between our conscious selves and the universe. So I'm going to say one or two things now. So where is consciousness? We all assume it's in the brain, of course. But do we really know for certain that it's in the brain? Can anyone with confidence hold their hand up and tell me with confidence that it's from the brain? And if you can, I don't think you're being truthful. No one can. Where does it arise? Is it the brain, the nervous system, or elsewhere? Is it external or internal? And more importantly, could it even be a global phenomenon, or is it an individual one? We don't really know. And there are ideas to substantiate some of these views. So I'm going to suddenly change the topic. Not really, but it's actually going to be very related to the same topic. Something that we don't talk about enough, which is the heart. Right? Why? Because here is an example of something which you can measure very easily, and it's the electric field, the electromagnetic fields of the heart. In fact, the strongest electromagnetic fields in the body, measure them all the time. In medicine, we measure them. But in fact, they are not just interesting squiggles on a piece of paper, they are interesting patterns and fields surrounding the whole human heart. So what we see is that it has a large number of nerves, and it even has sophisticated information encoding and processing abilities, and it can connect to feelings and emotions through higher parts of the nervous system. And the remarkable thing is this area of study in, for instance, the Sackler Institute for Consciousness, and we see this is an area of study in relation to consciousness. It's definitely been observed and documented that there have been changes in people, in their personality and behaviour after heart transplant. So there's something else going on here, another area which we need to look at. But the point I'm trying to make is there are changes in the, if you could see an array of colours and patterns around the heart, you would see that they are changing with emotion. So the question is, can the field, electromagnetic field of somebody's heart affect another person, or could they affect many people? We don't know, but we do see that there's a degree of awareness and empathy between each other. We don't understand why there's a distant understanding of how somebody else is feeling about you, or how you feel about somebody else is projected to other people. We don't understand. Anyway, so now moving on to the brain. It also has an electromagnetic field. Obviously, there are lots of nerves with electric currents, spinning around, and EEGs. These are other measurements made in medical practice. Could we use them to measure perception and brain activity? And the answer is yes, we can. And we look for patterns in electrical activity. So, can we find a link between those electric patterns and perception? And again, I'm keeping this down to very basic language, but to give you the buzzwords, neuroscientists tend to use neural assemblies. And from the language of quantum brain dynamics, we sometimes use neuropil forms or patterns. So what I'm saying here is that when there's a thought or a perception, large areas of the brain light up. Now, the word neural assemblies is very beautiful. It goes with the word almost, symphony. It means that there's a large collection. I don't mean just one or two. I mean a huge collection of nerves acting simultaneously. So there are some mysteries behind these patterns, some strange findings. There's no obvious, when it comes to perception, there's no obvious path. Now, this is an observation by Lashley in 1942 as a neuroscientist. There's no obvious path for electrical signals in perception or thought. In fact, there's not even a path. Distant areas of the brain work together simultaneously as if they're connected, but there's no connection directly between them. There is, but not such that it would connect from one area to the other fast enough to work together. So how do we explain this? It looks almost as if there's a field acting upon the brain. And this is where the physics comes in. There are areas of physics which deal with things like matter, whereby we model things in condensed matter we're using phenomena like condensation and so forth. And some of the behavior the electrical behavior seems to be like that. And so just to re-emphasize this, just in case anybody doesn't know what a neuron is, it's a basic cell of the brain. It carries electric current. There's a little picture, but just to emphasize, there was no obvious long-range nerve-to-nerve pathway. So the new perspective was developed in fact, initially in 1967, but that doesn't mean it's an old subject. Really, it's very new, and the developments are very current. There are many workers, Jibuyasu, Freeman, Vitiello, but the founders were Umezawa and Ricciardi, and they use the physical ideas to model this brain function. But even stranger, and this is the point of what I'm going to bring about today, which is the idea that there's a dual. Now you're going to ask me, what do you mean by dual? Well, I'll explain a little bit more in a moment, but duality arises as a result of the brain activity, that there is an immaterial, a non-physical aspect to this behavior, and I can say that it's unlike some immaterial activity, there's a calculable aspect to it, but there's no explanation. It is immaterial. It's in the sense that it's not a physical phenomenon that you can just grab in any sense. But it's a surprising result that shows that the activity of the brain is mirrored in another area, not in the actual material substrate of the brain, as a result of this model. And so, okay, here's a little bit of a little pictorial illustration of duality, slightly exaggerated, but the point is that, of course, there's a physical and a dual mode to this theory. So I don't want to spend too long on the physics because it gets technical, so I'm going to be very brief. The area of physics we're looking at is quantum fields. Now, the quantum field theory is a generalization of quantum theory. We've all heard of quantum theory. The quantum theory is a special case can be simplified down to quantum theory. Quantum field theory is a more general working theory of physics today. Now, the area where the study we're looking at is where there's a finite controlled measurable temperature. That's called thermofield dynamics. So that's enough lingo. I would just mention there are various ways of transforming and measuring these fields, and you find that there's a whole range of very low energy fields which are, if you like, very important in physics. So they operate as stable states, and this is where the duality arises. I won't say any more about that because we're in technical areas. So just a sort of visual illustration of what I mean by low energy, for the sake of those like pictures you see, here's a sort of Mexican hat potential, which is all physicists would have seen a huge number of times. Here at the bottom, you can see the lowest point in the hat is not like it would be in a bowl, but it's actually, because there's a hump in the middle, there's a ring at the bottom. The whole ring represents the lowest point you can reach in that well. So, but there's not one point. There's an infinite number of points in the circle. Each point of that represents the lowest energy state. And in this model, it's just a visual illustration. The lowest energy points can be any point along that circle as an illustration, and each one represents a stable state which will represent a memory or thought. That's how it works. So, a last bit of physics is just to point out that there's symmetry breaking involved. It's a phenomenon in physics where we have something which has a geometric symmetry or other symmetry, and here it's electric current, electric dipole of water molecules, and we find that there's a really amazing result that when something breaks the symmetry up somehow, and this could be a thought or a stimulus or a visual sight or a smell of a good tasting food, suddenly what happens is that there's a collective mode forming, there's a sudden long-range order. It's like suddenly it snaps into a pattern, and this is the physics that's used behind this type of brain dynamics. So this long-range correlation, by which I mean that pattern that's connected one end of the brain to the other end of the brain with no obvious pathway, and it's mediated through this breaking the symmetry of the electric dipole of water. So that's nearly all the physics. I'm going to sort of go straight on to the next phase, which is why are we bothering? Why is this important? I mean, is it really worth looking at this, and is it just another sort of newfangled concept, and why am I coming back to this? The reason it's important is because neural-based networks, which is the way that Yakub and all colleagues are studying in great detail, is the way that all AI is formed. However, neural networks, which form all AI systems, are unable to capture brain activity. So just repeat that. You cannot capture brain activity with neural networks, and this is a fact, and the only way you can get close to it are very, very difficult, complex ideas, like, for instance, at the bottom I mentioned Sakae et al. 2016 produced a very complicated CP1 plus U1 gauge theory on lattices. There are ways of trying to model it, but it only captures the brain activity at a very tiny microscopic level, but it's anatomically, the network has nothing to do with the brain structure. So, the point is that brain dynamics is worth following up because it is an accurate model, in fact. But what's more is that perception and actions in the brain activity are not only occurring in the brain, but they're mirrored by some immaterial dual activity. So have we somehow discovered something, and being bold, like the soul? Of course, we're not saying we can really calculate the soul with an equation. Of course you can't. I don't believe that. But we found something like the soul, something that's not material, that's acting on the physical. And the point is that it has major theological and philosophical implications. First of all, does it make any sense whatsoever that any non-physical facet of man can be consistent with science? Or more specifically, is a soul, even a soul in the theological sense, consistent with science? We saw Brian Pitts giving an excellent presentation yesterday, and he argued clearly that there was objections to that could not be strongly upheld or convincingly upheld in every particular set of parameters. For instance, conservation of energy principle and so forth. But also, which would have been nice to have Hans Halvorsen here from Princeton, who's also a physicist and philosopher of physics, who argues, and convincingly, that there is no lack of consistency with quantum theory. So we introduce some non-physical aspect to man. We cannot strongly object to it because there is no formal objection. It does not break the rules. So, some anecdotes, a little bit of storytelling. It's always useful to hear some stories. I'm going to extend the phenomenon of mind because so far we're being extremely rational. In fact, I'm remaining rational despite the fact what I'm going to say, which is actually based upon personal experience. In my medical practitioner hat on, with my medical practitioner hat, I've spoken to patients, and I have particularly seen the college called Arthur Findlay, which was quite close to one of practice, and I regularly saw people coming along from this to study psychic phenomena. And one person came along as a woman from the USA, and I said, "What's your special area of psychic skills? What sort of phenomenon have you mastered?" And she said she hasn't mastered anything. She said that the FBI and the police often ask her things. And I said, to give me an illustration. So she said, well, they asked me about a murder that had occurred, or a killing that had occurred somewhere in the USA. They wanted to know, who did it, where exactly it was, which time, what sort of weapon. So she described this story of a man sitting in a desk on a desk somewhere in another state, in a particular time of day, holding a gun and putting the gun in his mouth and shooting his head and killing himself. And they went to see it, and exactly what she described was found. So I said, this is remarkable. So the FBI and police and so forth, they use your service. He said, what do you see? She said she has no idea whatsoever, she just sees it instantly, every detail. And there are many stories like this, and this is not an unknown phenomenon. The psychic phenomenon is used in a sort of formal setting, and it does happen, certainly with investigation and police and FBI and so forth. We also know, and this is not also, though it's anecdotal, we can all poo-poo it, we know that identical twins have ability to be empathetic with each other's feelings. so forth. So I'm going to move on a bit because I'm conscious of time here. So the question is, what is actually real anyway? If we are just matter, where are we? They're all very confident in this room that we're sitting in this chair, but the truth is, we're just a collection of atoms. In fact, if we look at the atoms in our body, we're actually from some distant star, these atoms come together, and the atoms themselves are essentially mostly empty space. So we feel a sense of solidity or any substance because of the fundamental forces. But in fact, atoms are they really real? And the truth is, the modern theory of quantum field theory shows that actually, though they are real in the sense we perceive, they are actually just fluctuations on some sort of quantum field. They're not actually real in the sense that we believe that a football is real. They are just a fluctuation, energy variations on a field. So the question is time even real? And in physics we deal with complex time and notions that arise more complex than that from causal set theory. Or are we just even a holographic projection? I have supervisors at Imperial College right now who are specialised in ADS CFT, which is anti-de Sitter space conformal field theories, which are otherwise known as holographic theories. So are we saying it's dual, or can we just poo-poo this idea? Could the dual be a clue that some other facet of man yet to be discovered that is responsible for our perception? Is it the real us even? But our judgment will bias this opinion, of course, because we're all very familiar with ourselves as we are. What about panpsychism? Could we just extend the idea of consciousness to that a global consciousness, perhaps everything has a degree of consciousness, and now there are ideas in physics coming from integrated information theory that perhaps consciousness is not such a biological phenomenon at all. In fact, it could be that even a complex collection of particles could have some features of consciousness, and it could be a global phenomenon, and maybe even carried by fields. So the next question is, does consciousness and mind continue after death? And this is important because it relates to the point I'm going to make. The biggest study in a more rational, in a more objective setting, more accessible to people, is by Dr. Sam Parney at Southampton University, which is a very large study over several years, where the conclusion really is that some of those people studied in the cardiac arrest and post-death situation had documented formally in a clinically controlled setting awareness of full conversations and seeing things that were going on around them even after they were pronounced dead. Okay, we can poo-poo all this, but this is a clinical study. Okay, so when he says this, he's not saying somebody could just about hear what they're saying. The point is lucidity was as lucid as it was somebody who had not been dead, and it was not from the perspective of the person lying in the position of the person who had actually died, but from other perspectives too. And there are lots of demonstrations of this, and a lot of studies. I've just mentioned Raymond Moody from the 70s, but more recently even Alexander with a very profound account. So does consciousness continue? We know this is a fundamental aspect of faith, and physicists have even vouched for this in different ways. I'm going to skip that slide now. So to be careful, are we actually real? Well, perhaps you're not as real as you think you are. Perhaps you believe with conviction what is real is actually just an illusion. Or perhaps what you believe is not real may actually be the true reality. So the concluding points now, concluding two slides, is that we've postulated that in this conjecture, in this model, that the action in the brain, the matter, has a double which is proposed to have actual function and perception and awareness. And the largest result, probably, of what I'm going to say, which should wrap it up, is that from the studies on real humans and real animals and controlled studies over many, many years, the conclusion of the 2016 paper by Freeman and Vitiello is that the activity of the brain cannot be separated as mental, or in other words, non-physical, by which they mean mental, activity versus brain activity. They're intrinsically related, dynamically entangled in a precise, formal way shown by the many-body model. So the final slide is that the quantum brain dynamics leads to a remarkable conclusion that mental activity may in fact not be entirely physical in the sense we believe. The brain may be controlled by mind or soul. using the words that we have to use. And that all physical mental function is associated with an indivisible, immature dual mode for every human, and that brain activity in an empirically observed settings cannot be separated as mental, non-physical, versus brain and matter. So science is actually finally discovering that there is a lot more to us than matter alone. That's what. Thank you.
Cambridge Muslim College, training the next generation of Muslim thinkers.